All right, welcome everybody. Thank you for joining us at this session at sort of getting towards the end, the home run of this meeting here. God, I've really become American talking about home runs. Yeah. Okay, this is a session organized by the RDA Interest Group on Physical Samples in Digital Research Data Management, and we want to focus today on cross-domain metadata schemas. This has really been at the core of this group. But what we realized is that this group has been around for quite a while, and a lot of efforts have started over the time that we've been working, and we still have not managed to come to a joint definition on, what do you call a sample and how you describe it. And so this was a good time to take this as the focus of our session today and hear from, hear from various communities what they're doing as examples of their metadata agreements, metadata standardization. A big discussion I would like to see on this big spreadsheet that we're compiling within this interest group to identify all the different efforts that are currently going on in different domains regarding sample description, sample metadata, and see how we can use this enormous resource that has been compiled to actually make progress towards, towards the common denominators in the sample schemas. How do we describe samples across domains? So with that, first of all, we should acknowledge and celebrate the first Australians on whose traditional lands we meet. And pay our respect to their elders past and present. We should also do and think about it similarly of our own affiliations and where we work and who has lived there before, and acknowledge that always. Do we have new RDA members in the room? Anybody? That's a good question. I also think if you're attending an RDA meeting for the very first time, that's also, a good way to think and, how do you interact, how do you integrate, and, that's when I think these 6 principles that we've been showing in these sessions are really important, that we want to maintain this community-driven aspect of the RDA, bottom-up openness, building consensus. That is sort of, to me, the bottom-up versus top-down, non-profit and technology-neutral, harmonization, I would say, both on the social side as much as on the technical side, and having inclusivity. That is not good to have that white writing on that light background for inclusivity, because it needs to be very much emphasized. Anyway, so we have our agenda here. We want to start off with a review of this catalog that has been compiled of groups and projects working on physical samples, not only their identifiers, but also metadata schemas and best practices around the samples, I would say. Then we have 4 lightning talks. The first one from Kirsten Elger about the IGS-NEV metadata working group. The second one from the archaeology community of practice within the IGSN organization. Then, is it Eli or Eli? Yep, Eli Wallis from GBIF, obviously about biodiversity specimens and metadata. And last but not least, Rolf Krahl for material sciences. We want to hold a community forum on comparing and contrasting what is a sample and seeing if there are universals in the metadata. That will be a discussion of the group present here, and we have assigned quite a bit of time to that so that we actually can have some outcomes maybe. And then Jens will close up the meeting in 90 minutes, or now it's in 85 minutes. So with that, the review of the catalog. Jens.
Hello, I'm Jens Klump from CSIRO, and also involved in the IGSN. The slide that's missing now is the QR code to the collaborative notes. Sorry about that, but you can find that page through the meeting program app, which is, sorry, a little bit roundabout way, but if you can find it and add your name to the list and of participants, that would be very helpful to plan future activities, and if you have capacity to also add to the notes, that would also be great. Review of the IG's catalog, so that's why the notes would also be helpful, because there's a link to Google spreadsheet with 2 tabs. One tab lists all the activities that are known to this group that deal with samples and metadata for samples. And the other tab in that spreadsheet deals with vocabularies and ontologies that describe physical samples. And collecting both information about the activities and about the outputs that they have produced in terms of vocabularies and ontologies has been very helpful for us to get a better understanding of where activities exist that we hadn't known so far, and to start even more appreciate the differences and commonalities between disciplines and sub-disciplines. So if you can find that link in the collaborative notes, we invite you to contribute to the spreadsheet by adding further groups that you know of that are working on physical samples and describing physical samples, or if you know of ontologies or vocabularies that are being used in this area, and add those to the spreadsheet. I think that's as much as we can say and do about that now. And we move on to the first lightning talk.
Hi, for those of us who have seen me before, I speak yet again about IGSN and metadata. This time as part of the IGSN EV Metadata Working Group. And I don't know how many of you are aware of what is the IGSN, so I'll just briefly wrap up. It's called International Generic Sample Number. It's a persistent identifier for physical objects and specimen, developed even before 2011, because it was 2004, but the EV has been founded in 2011, which is the organizational group that is managing IGSN. It is mainly a QR code on samples that persistently link to online sample descriptions. IGSNs have never been intended to replace sample names, but provide additional reference and make it unique and resolvable. They are citable in scholarly literature, and everyone is encouraged to do so, and as such enable tracking of samples through the literature and through data publications. Without that, it was really, I think it's still challenging, but with the IGSN you do is, since 2023, IGSN, no, it started actually 21 and 22 when there was a strategic partnership between IGSN, EV and DataCite, and the development was towards using the the DataCite technical infrastructure for the scalability of IGSNs. At that time, we already had 10.5 million registered samples, so we did not start from scratch. We had plenty of them. And since 23, they are technically data site DOIs. If you want to know more about IGSN, there's this review article led by Jens and others that is describing everything for 10 years. The core of IGSN is the modular metadata schema. I don't know why this is black, but it's called, the white thingy on top, it's this insert into Google Sheets. It's the registration metadata that we used for the handle, and this was meant to be very, very limited metadata properties that that every agent had to provide. So these were the very, very few mandatory. And then we developed we called a description schema that should represent the common kernel that would support data discovery, or sample discovery actually. And this has been, IGSN they originate in the earth sciences, so you will see geolocation, which is for us a very normal case. And then it already had the flexibility of being added by very specific sample type specific metadata elements. And with the merge of DataCite, the challenge was that we had to look into some mapping between the modular IGSN metadata, highly granular, very specific to different sample types, not even beyond the earth sciences. So geologists, they're also paleontologists, so we speak about fossils, we speak about plants, there's ecology involved. So all these metadata profiles were highly specific to comprehensively described metadata samples. And on the other hand, where is this? Okay, here we go. On the other hand, we had the DataCite metadata schema that is mainly for providing citation information, for bibliographic information, but then, I don't know why this is added again. If you read the metadata working group's description of the schema, they say it's for citation and to support basic discovery. So we see two different purposes between the IGSN metadata schema and the DataCite, because IGSN is very granular, specific, and rich to get comprehensive sample descriptions, whereas DataCite is developed for citation and basic discovery. And I'm just saying this because sometimes it doesn't make sense to put everything in DataCite, because it's not the purpose. So we should rather think about linking metadata schemas. Let's see what's happening. During the transition, there was, and it's still ongoing, a partnership steering group between IGSN and DataCite. And the first thing we did was, or one of the first things we did was to develop IGSN metadata recommendations for the new registration form via DOIs. And this had to be done, I hate Google, look at this, there's these odd things. Okay, nevertheless, this had to be done within a few months' time, and the purpose, of course, to re-register all the 10.5 million identifiers that were minted by 10 agents, so it was not just one institution involved, within one quarter of a year with DataCite. So, of course, we focused the initial mapping on the DataCite's mandatory properties, which mainly serve for the bibliographic information. This is still the most actual document, and after this mandatory fields, there were some very, very few recommendations, but it is absolutely clear for everyone who's related to IGSN EV, who has ever minted any sample identifier, that this is definitely not appropriate and enough for describing samples. So it has never been intended to replace the IGSN metadata schema. Status and challenges. And I now repeat what I said about two days ago. The major change was that each DataCite member can now just assign IGSNs. DataCite recommends to use dedicated IGSN ID repositories to enable the separation between data and samples, which makes a lot of sense, and with separate prefixes, which is also not a problem with DataCite. But there is no central governance by IGSN EV anymore. IGSN EV keeps keeps existing, and of course we would love to continue our discussions because we see ourselves as the group who has a lot of experiences with how to describe sample and how to use the metadata for that. Oops. In addition, IGSNs are already registered for other disciplines. For example, material sciences and archaeology will come up. Jens will follow this talk with an introduction to the metadata schema for IGSN, for archaeology. And this is really important, there's a high risk that the diversity in sample description is further increasing because there's we lost the central governance. So this means if everyone, and I heard mentioned that, oh, it's so easy to register IGSN now because you just have to provide the mandatory metadata fields for DataCite, and this is just not true. It is legally okay, but you would lose so much information and you would really lose the findability of samples. And of course, with this, if we ever think about, and we discussed it for many years, the development of a central sample catalog, using the mandatory fields only, and especially seeing how some IGSNs, the title is just the number, which is random. We will never be able to build such a thing. There is the IGSN EV, I forgot the EV, Metadata Working Group. We have members from different institutions in the earth and environmental sciences, but of course we are very open to get new members. One of our tasks is the revision of these IGSN ID metadata recommendations with the focus more on recommended or even optional fields out of the metadata schema. It still doesn't mean that we can fully use the DataCite schema because it's not the purpose. And two of these properties I have highlighted. One is the subjects, where we have the possibility of including linked data vocabularies by addition of the IRI and the scheme IRIs to really make it machine readable and understandable. And the other is the related identifier, which is essential to connect samples with data and papers. And of course, we will have discussions with new domains like IGSN Archaeology Community of Practice, and IGSN members representing material sciences. We have recently received an application as member of the EV from the Johns Hopkins University, which brings in material sciences, and it would be lovely if that person joins the metadata group, because one of the tasks will be to revise this common kernel of metadata that might be suitable within the geosciences, but definitely not beyond. So the question will be how much can be kept from the original, or how can we really agree on using one, even a handful of properties that can serve or can be added by most IGSN agents. Okay, and with this, I just add the website and some contacts if you are interested. I don't have a QR code, but it's easy enough, and I thank you very much for your attention.
I'm giving this short presentation on the behalf of Thomas Rose, who was one of the members of the IGSN community, archaeology community of practice. I was also a part of the discussions, but I'm not an archaeologist, so I will just report on it and reuse Thomas's presentation with his permission. So. The purpose of setting up this community of practice was to see what the requirements would be in archaeology to identify and describe archaeological artifacts and align that with the technology stack that IGSN and DataCite use to mint identifiers and put them into and put the descriptions into catalogs. So this group met quite regularly since March 2022, first as a kind of a pilot of what these communities of practice could look like and how they would operate. And they were, the group was joined by IGSN and DataCite representatives to help them move along and keep them connected to both organizations and their workings. The archaeologists came from different backgrounds within archaeology, like archaeometry, landscape archaeology, and data management, and other parts of subdisciplines of archaeology. All of them shared an interest in material sample management, data collection, and the publication of that information. And on average, 13 people worked with this group. The primary goal was to promote the use of persistent identifiers for archaeological samples, and we worked on articulating the use cases and workflows within the disciplines, which was very interesting because you would think archaeologists all do digging up stuff from the ground in a very meticulous way, but hey, no, there are very different ways of conducting archaeology, and not everything is about digging up stuff. But then also to describe samples in terms of minimum and extended metadata profiles. And that started as a conversation of saying, this is how I describe things, or this is the forms my community uses to document their work. And what we saw, of course, isn't surprising. There's a diversity of use cases and practices. There's a diversity of describing artifacts, assemblages, and locations. And then there's a diversity of recording provenance and access to those materials. So as outputs of this community of practice and its work, we produced a number of newsletters, webinars, and conference presentations at relevant archaeological conferences, and also through the NFDI for Objects work in Germany. Also to broaden the membership in the community of practice, which did work. So it wasn't global, but at least it did cover Europe and Australia. So Germany, France, the UK, Bulgaria, and Denmark, and Australia. We conducted a survey among practitioners about the potential for using persistent identifiers or existing practices, and developed a sample metadata profile and a crosswalk of that metadata profile to the DataCite metadata schema, resulting in a crosswalk recommendation. So the workflow was over this time to start with something concrete, which was some material sample provided by Penny Cook from Macquarie University, and describing that, and then comparing that with existing metadata structures like in the Archaeological Data Service in the UK, which resulted in a prototype profile, which was then discussed further and cross-checked with metadata needs across the disciplines, resulting in the first version that went through another iteration and refinement, and a second version, which then was discussed with the community. And at this point, we also developed the crosswalk to DataCite and developed what's now called Metadata Profile version 3.2. So what we really paid attention to was the consistency with previous work, both what had been developed in the Geosciences community, but also what existed as the DataCite schema, the IGSN descriptive metadata schema, and the crosswalk that the working group between IGSN and DataCite had already developed. So no reinvention of wheels, even though this is often tempting. So what we had done so far was to review the metadata profile and recommendation revisions based on community feedback, and then approval by the community of practice members. And the step that is imminent now is that this will be published online and made available through DataCite support pages, etc. And then go out to the community again and promote this and the use of the schema. And I'll hand over to Eli to tell us more about Dublin Core.
Okay, thank you. So off to the world of biology. So I'm Ellie Wallis, and I work as the Engagement Manager for the Atlas of Living Australia. And I also have a lot to do with the Global Biodiversity Information Facility, but I don't actually work for them, but we will be talking about things that biodiversity data, which encompasses data in both the Atlas and in GBIF. So I'm here to talk to you about an international data standard used by the biodiversity community, which is called Darwin Core. So Jens just referred to Dublin Core. Dublin Core is a different international data standard, which is used very widely to interchange data used by the library community. And there are certainly elements of Dublin Core in Darwin Core, but I'm not specifically going to talk about Dublin Core today. So we use Darwin Core to interchange data about biological organisms across all phyla. So deliberately not saying plants and animals, because there are more phyla than just plants and animals. So it's managed. Darwin Core is managed by an international group called Biodiversity Information Standards, more commonly known as TADWIG. There is a reason, but just live with it. And so it's Darwin Core was developed a number of years ago and is currently in a transition phase to a new type of Darwin Core, which I'll talk about in a second. And so it's primarily based on interchanging data held by museums. It was originally developed for interchanging data held by museums and herbaria about species. And the occurrence data is the current kernel of Darwin Core, which describes a species or a taxon that was collected in a place, on a date, at a time, by a person. Now, those of you in the room who are interested in machine observations will immediately go, a person? Oh, we don't need those anymore. And so that's one of the reasons why we are looking at a new type of Darwin Core, which will accommodate machine observations, drone data, camera trap data, sensor data, and then we've also got the whole genomic data collection through eDNA that's coming through, which is going to revolutionise everything for everyone. So, Darwin Core works into... Sorry, I've confused myself already. So, as I say, it arose as a development coming out of the herbarium and the museum community. The vocabulary that is probably most relevant to the discussion about samples in the current Darwin Core is called the basis of record. And the list of recommended terms for basis of record is up on the screen. There's in there, you've got preserved specimen, fossil specimen, living specimen, material sample, and material citation, material entity. It's a bit of a confusing vocabulary that's a bit all over the place, and that is also one of the things that the community are working on and hoping to improve. Now, I'm told that in the past there's been a very active discussion about what the difference is between a specimen and a sample, and Lesley told me I was not allowed to reopen that discussion, so we'll just leave it at that. But just saying, we've got both specimens and samples currently described within Darwin Core. Darwin Core can also sometimes, it's not used as the basis for data collection by museums and herbaria. It's too simple. It's really designed as a data interchange standard. But it is now used as a basis for data collection, for example, for citizen science observation records, which it does do quite well for. So it was designed to reduce friction in data publication across biological organisms. So, as I've just mentioned, it's become very obvious that the Darwin Core data package needs to be richer. And Darwin Core data package provides that opportunity. So there are some compelling examples, like I've just mentioned, about drone data and machine observations that are too difficult to deal with in the current version of Darwin Core. Even for museum specimens, it's too difficult to explain the relationships between a specimen that you might collect in the field, then you take a tissue sample from that specimen, then you do some genomic work to derive some DNA from the tissue sample, and those relationships cannot be well expressed in current Darwin core. Even the fact that you've taken a physical specimen, if it's a vertebrate specimen, it's very common in museums to have the skeleton, the skin, the skull, and the tissue sample all held separately and dealt with separately. And Darwin core doesn't deal well with those preparations either. So we needed something that's going to be richer. So TADWIG and GBIF have really driven the development of the new Darwin core data package, and it follows use cases to investigate how the user communities, what the user communities needed and what they wanted. So we've been talking to the machine observations communities, we've been talking with the collections people around the collection management systems, environmental DNA, eDNA, as I mentioned. There's also interesting interactions, the interactions community, so the parasitologists, for example, or people looking at biotic interactions like predator-prey or symbiotic interactions have long wanted a much richer expression of how they can deal with the data that they're interested in. So there is, no, I haven't gone fancy QR codes, there's a URL up there that you can look up if you want to read up on all of the use cases that were developed. So we're trying to be careful not to say the old Darwin core. There is no old Darwin core. Darwin core in the future will remain the bag of terms that it always has been. The Darwin core archives will remain as the way to publish Darwin core around the simple occurrence model, which is the currently used publishing model for Darwin core. Whereas the Darwin core data package is a new, different publishing model that using Darwin core that lets us be preciser and richer than we have been with Darwin core archives. And we've proposed an added conceptual layer so that people know that when they're talking about an occurrence or an organism or a sample, or how does that, and so that we can actually express those relationships. The idea with the Darwin core data package is that it can be used in a modular style. So for example, one of the worked examples that we're dealing with is the GBIF metabarcoding tool, and that only uses 6 simple CSV linked tables. So in some cases, the Darwin core data package is producing data sets that are 100 times smaller in Darwin core data package than in the current Darwin core archive, because it lessens the repetition that you have to do. In the Darwin core archive, which flattens all of the relational tables out, you end up with a lot of repetition across records. So the aim is to govern the Darwin core data package schemas within TADWIG and manage the vocabularies within TADWIG. We've increased the capacity of the Darwin core maintenance group in preparation for this, and we hope that that we'll be able to centralise the training and support material within TADWIG and not fragment it across GBIF and OBIS and all the other users. It's currently under peer review prior to ratification, and there's work underway to develop the vocabularies around terms such as basis of record, so the thoughts of this interest group are very timely and very relevant. And with that, I'll hand over to Rolf. Thank you.
Yeah, thank you for the invitation to speak here. I was announced as material science, I was announced to represent material science, which is not entirely wrong, but is also not entirely correct. So I'm coming from Helmholtz-Zentrum Berlin for Materialien und Energie. So we operate a synchrotron light source. So we are not located in a particular, say, scientific domain. We are representing a class of experimental methods. And these methods are used by scientists from all the domains. Having said that, material science is a big, say, player within our facility. And looking at the samples that we have in our facility, the first thing that you see there is a huge variation of things. We have more or less everything. So we have simple things like single crystals, crystal powder, functional materials, something like that. So chemically, very simply, say, composed. We have complex structures like batteries, solar cells, little devices that we look into. We have macromolecular crystals, which means proteins that you use then for that you apply crystal diffraction on them in order to, say, investigate the 3D structure of the protein. We have organs of animals. We have archaeological artifacts. So the neighbor sky disk was once in our facility. We have fossils. We have artwork, paintings, lots of things. I could continue for more or less forever. All of that within one single facility. And it comes even more complicated because we also have what I would call ephemeral samples. That are samples that are created, measured, and destroyed within one single experiment. Like a liquid jet that is pushed into the light beam and then, say, investigated with optical measures. Or we even have single ions as a sample. So I'm a little bit probably the skeptic here in the room whether we come to a, say, common metadata schema to describe all that. But I also represent the new sample type classification working group that had its kickoff meeting on Monday. And here we follow, I would say, a comprehensive and additional approach to that. And that would be, of course, all of these sample types do have, say, domain-specific description schemes. Or not all of them, but most of them, I hope. But these domain-specific schemas are limited to their domain. They do not apply to other samples outside that domain. And as I said, I'm a little bit skeptic about a common standard applicable metadata schema that would work for all the samples. But if we come up with, say, standardized vocabularies for the type classification, so if we can say this is a battery and this is a fossil, and if we then know, if we know the type of each sample, then we can probably apply domain-specific vocabularies to describe it. Of course, in order for that to make sense, we would need that type classification be a controlled vocabulary, a standardized thing. And that is exactly the task that we took as a working group, that we want to develop or come up with one standardized vocabularies for the sample types. With the idea, so once we know it is a battery, we apply that info to describe it. And this classification vocabulary would, of course, need to be very broad, because it needs to cover more or less everything. But it doesn't need to be deep. It could be very shallow. It could remain at the very top classification layer. Fossil, battery, solar cell. That's it. And therefore, it's not about replacing domain-specific vocabularies, but to connect them. And that was already my message. The first task that this new working group wants to endeavor is to collect community input. And this is now a call to all of us, all of you. Please come to us. We collect at the moment, or we just start to collect case studies which hopefully would give us an overview of the sample types around, and of course that pretty much relates to the activity that Jens is just undertaking, I hope. So we should, of course, join forces here. Yeah, and so the status of the group, we had the kickoff meeting on Monday, and this poster that is still hanging over there is describing how you can contribute to that task of collecting community input. And with that, I thank you.
Oh, great. Coordination. So what did you hear that you get either very skeptic? I thought it was really interesting how Rolf is skeptic about actually getting to some common approaches. I think we should be a little more optimistic about it, even. And actually, I just wanted to add to these presentations. I had been involved for 4 years in a project called the Internet of Samples, which tried to bring 4 different domains together. It was the earth sciences, archaeology, biodiversity, and at a more general level, a museum collection from the Smithsonian Institution. And it was 4 years of work to just come to a little bit, but there is a common metadata schema, but it's still very focused on the natural sciences and doesn't have samples beyond that in it. So I want to open up the discussion for anybody to bring in your skepsis, your yay. Do we have the... Excellent.
Hi, thank you. This is great. Believe it or not, I am actually so excited about a sample type vocabulary. This is like my dream for the last 5 or 7 years. That's a bit dorky, isn't it? But so I'm from the soils community. My name's Megan Wong. I'm with the ARDC, but I'm asking this on behalf of my research position. I worked on the Australian National Soil Information System. We were brought in to do the schema, the ontology, what vocabs we can, and then the informaticians moved off. And my experience is with other soil information systems and other information systems, informaticians and people who love vocabs and moved on and off. Resourcing's patchy. We all keep in contact, but we don't necessarily have the opportunities, the funded opportunities to work on things like this. It seems like little passion projects on the side. So I'm really interested. It's a hard thing to pitch, right? Oh yeah, I want to do that. It's not particularly shiny, is it? So I'm interested how the geology community and how that group worked, whether it was voluntary, whether there's...
Do you mean this Internet of Samples, or...?
The group that Jens was talking about with the
archaeology.
The special interest group or whatever it is. How do you get these groups seated? How are they resourced? Is it voluntary? Just interested in your experience. Sorry, that's long-winded.
In the case of the archaeology community of practice, it's a mixed mode of people who are funded to do this work through DataCite and NFDI for objects, and voluntary work of people who are interested in the topic. And that, of course, as with all these groups, puts limits onto what you can actually achieve. So I'm actually very pleased with the outcomes, that it's now at a publishable stage.
Yeah, this Internet of Samples was a funded effort that was specifically sold to the funding agency as something that would make discovery and reuse of samples easier by combining it, different, or the metadata of different entities of different domains into a single discovery portal. So you can sell it, but it's, as usual, a time-limited effort. And, since for us the iSamples project has ended, there is no maintenance, and efforts like this are, the discussions like this are difficult to participate in and then make changes as things evolve, which we hope they do, through discussions seated at these meetings. Yeah.
Hello, Marek Cvecar, Herovsky Institute, Czech Republic. I would be a little bit less skeptical than Rolf. He knows me, I'm always optimistic. Especially nowadays in the time of linked data, we need to agree on some relatively basic high-level information, and then we can connect it with the data schemas already mentioned by a colleague here. Because if we know, and the classification again can help, Rolf was speaking about, because we can have this class, sample class connected to an agreed schema, and the schema only applies to this class, there is no problem to bridge it in a linked data world. So that's why I'm much more optimistic this can be done. We should just not forget, as you correctly said, we should not forget about some type of samples which are not coming from these main fields which are already established. And the question is if we have to, if we should focus only on physical samples, and we should not step out of this, because in the time of AI and similar systems, we need to be prepared for more complex questions.
No. Yeah, oh, Ilya, please.
Yeah, that's sort of a segue to the previous question. Ilya Zaslavsky, University of California, San Diego. So, sort of a segue to what Marek asked. There are many different types of samples, as we saw, and it will become increasingly more difficult to come up with a common framework to describe all the variety. At the same time, within standards communities such as OGC and ISO, they've been well-developed and kind of historically well-developed systems such as observations and measurements, I believe observations and measurements and samples in the most recent incarnation, which are specifically meant to provide such a framework in which I guess IGSNs and physical samples would map to just one component of such a system, a feature of interest, probably. So my question is, what is the relationship between these two threads, and if there's a plan to adopt a common schema like that, so that you can reuse the tooling and kind of make it more, address the problem of variety of samples from the start?
I mean, from my perspective, clearly we all use some way of encoding the information that we keep about the samples, and in my implementations, we have tried to stay as close as possible to observation management and samples. What we need, I think, as this community is to move towards a vocabularies that we can use at the highest level, be it sample types that we're talking about, material, consistent vocabulary of material and so on. And probably, some common structure that, I don't want to be, again, I'm not the optimistic person usually, but I do think that, as you said, there is a framework, there's a concept already out there. We just have to fill it and be a bit more specific to make it useful for all the applications. And that was the insight, I think, for me from this iSamples project. And other discussions, I see Steve in the background, and discussions that we had within the CDIF development context that maybe you can say some to it.
I'm happy to. Yeah, I mean, how many years have we been? We're on our third year of iteration, I think, on trying to reconcile physical and social science samples, as an example there. And I think that we've got a bit more to come in about a month's time to pick that up a bit further. The observations and measurements sort of space there seems to be so pick up your point there, that seems to be the point of some convergence, but vocabularies really matter here. It's, I mean, long and involved discussions certainly that have gone on amongst the groups there about, I mean, we're just not talking about the same thing. So what is the concept? Pull the terminology out of that. What's the concept that actually comparing here has been really, really challenging. So, in fact, it goes back further than that. I can remember Simon Cox.
I think that's what Lesley said. Well, Lesley said.
Yeah, Lesley said, don't do this, for a good reason. But yeah, I think that's the right track. But we for CDIF, we're continuing to kind of hit upon this and go, how do we actually get? At what point can you talk cross-domain, and at what point does the domain terminology just get? You're just no longer talking the same thing. So it's that reconciliation, and it is the standards organisations that are probably the place there. So yeah, I think that's to me is probably the direction of travel. But the specifics have been really, really hard.
And that, I just wanted to come back to something I said earlier. I think for us a real goal for this session is to figure out, what are the next steps, what can we do? And are there ways to now look at, this list of efforts that are going on and basically explore, how can just an agreement on, let's start off with observation, measurements, and samples. Can we use that to map all these different schemas that are around the metadata, and as a first step to explore how far we can get to a common denominator? I mean, it's really about ideas, so I'm looking for all of you to put your hands up and come up with solutions, because I think the fact that this room is actually pretty well filled is to me an indication that there is a lot of interest in doing this. And we have always had our biology collections and geology collections, and over the last at least 5 years, if not longer, I've seen more and more a broadening of management of collections. And I know that there have been biological sample management systems are extending into the geo world, and the others, like IGSN goes into material sciences and so on. So we really have a need to respond to this and make something happen. I saw somebody.
Yeah, David Lisinski, Geoscience Australia. I think we could take multiple approaches to this at the same time. One of the approaches that might be useful is that Jens presented the archaeology example. We've been working in the geosciences space for many years, and even within that we recognize you may have to have different types of classifications. But another approach would be to take it from that practical standpoint of what is important to an individual domain, collect a whole bunch of these examples, and then see where you have commonalities that can then be mapped together. Because as Kirsten mentioned, one of the goals had been from the very early time was to set up some sort of centralized discovery network. Yeah. But if you want to have a centralized discovery network, you need to identify what are those common elements that enable centralized discovery. Because if it goes down to, you know, batteries, if you're interested in batteries, you have this discovery system. If you're interested in, you know, in fluids that are artificial, you're interested in this discovery system. But if we had a bunch of different examples from a range of different use cases, that might be a starting point. And it would also have the benefit of enabling groups that are actually doing this to put a framework around it rather than waiting.
Thanks. Kirsten, Elger, GFZ. I think it's really important what you say, and especially because we are not starting from scratch. So I'm not as pessimistic as Rolf, but I think we have the means to really develop. What I would suggest, well, I think it's two points. One is to agree among persons or groups that are willing to do so on common standards. But then I think to have the full implementation, we would really need to, all the groups that actually register identifiers for, or IGSN for their samples, or they might not all be called IGSNs, but identifiers that they actually follow our recommendations. And I would suggest, as a practical first step, to consider to include the new group on sample type definition in our interest group as like a spin out of the group, because this would enable us to bring in more communities than we are currently having.
Thank you. I really like that suggestion. So it's me again, Jens Klump from CSIRO. But I want to support Rolf's view. I think there are really limits to what you could do if you, with the qualification that you need to define a purpose. Why do we want to describe them in a certain way? Just describing everything for everybody, I think that's what's not achievable. And so, some use cases like what did go through my synchrotron light beams is a specific use case that requires a certain way of looking at the world, while what is it that is in the box on my shelf and I run it through a mass spec is a different view of the world. And then they are, and then if we then want to exchange information about that, it's again another use case where we can look at, so what terms do we need to be able to communicate about that? But if we don't define the use case, then I think we would easily waste a lot of time. So I think we need to talk about why do we want to do this.
Just one comment to that. I would be, say, careful not to concentrate too much on, say, the use case of the current investigation of thing, because the same object may travel to different institutions and may be investigated by different ways. If I say so, the Nebra Sky disk, well, it was a sample in our synchrotron, but it's still mostly an object in that, say, collection of archaeological, and it will certainly be investigated by other groups with completely different methods.
So to reply to that, but it's still, I think that doesn't invalidate my point that in Rolf, in your context, you have a certain way of looking at it, while at the museum in Nebra they have a different way of looking at it, and we don't have to adopt all views at the same time just because they exist. We have to, I think, for this interest group, we should look at what use cases do we want to facilitate, and what terms do we need to enable those use cases.
So I did not see who had the hand up first.
Oh, thank you. Megan from ARDC again. Aside from getting dorky about wanting to give everything a name, label everything. Driving use cases would support the development of your models, etc., resourcing. So around use cases, what is in it for? What are the incentives for? This is a little off topic, maybe. One archive I spoke to said, "Well, what's in it for us? What would the resourcing be?" Because they've got an entire local, their own internal numbering system, and why would they bother changing? Like, we can see why, but because if they could see the value of IGSN demonstrated, then that can drive this and this work. And you could say pass on it. It's a bit off topic.
It reminds me of decades of work in promoting the use of the IGSN in the initial days. And most of the larger organizations, museums, sample repositories, and so on, really bought into it because of the central discovery aspect. They wanted to make sure that their collections can be found through more ways than just their own local database. In some cases, they didn't even have anything online. They had, their Access database or a spreadsheet internally. So that was much more than the fact there is now a resolvable and persistent identifier that didn't actually go down well with many of them, especially large museums that said, we have our own numbering system for the last 200 years. We know how that works. We don't need another identifier. So it's, I think that's where the attraction of the initial IGSN was, that it was earth science focused. And so within that domain, it allowed different collections to be discovered through a single access point. When it comes to cross-domain, we actually in this, the proposal of the iSamples project had a whole list of use cases where a sample need to be findable from different communities. And, was water samples from New York City that had biological components in, so they were archived in or stored in local hydrology organizations, but biologists were interested in them. So it would be really great to extend this spreadsheet that we have, I think, into something that gathers use cases. Why would you be interested in actually mapping your metadata, your much more detailed and domain-specific metadata, to a broader, more generic schema to make it work, to make some, what's the incentive, as you said. And I see soil samples actually as something that is very much of interest to communities way beyond soil sciences or environmental sciences. So I think there are many great ideas to be had if we just have a place to gather all this. Ilya.
Yeah, so to continue about use cases, maybe we might focus on sufficiently narrow domain where there are multiple ways to describe samples. If you look at water samples and follow, let's say, water markup language, there's a way to describe samples in O&M compliant way, and there is IGSN way to do that. Perhaps within a narrow domain, the mapping can be done easier. I believe in soils, situation is similar. There's soil markup language that is O&M based, and then there's IGSN based samples.
And that moves to SOSR-SSN, like lots of other.
Yeah, I don't know much about that. I know a lot about water. And then, of course, the requirements from different use cases are very different. I would say that on findability and overall management of domain metadata, IGSN beats all these other schemas hands down. Working with O&M is not the easiest thing, and indexing it. So it would be good. Actually, all of these examples coming from WaterML or coming from IGSN come with use cases. Maybe the first thing would be to see how different they are and what they emphasize.
Yeah.
And maybe different approaches would coexist if the needs are sufficiently different.
In the, another lesson that I've learned in the long-term operation of IGSN and a sample registry has been that even a given sample has different requirements for different people, because it's, and that's sort of along the lines of what Rolf was saying. People want to use it in different ways for different science applications. And so they're looking for different types of information about that sample. And we can't predict all of those because the new questions arising in sciences that where people say, well, do you know anything about that? Yeah.
Sorry, I'm just going to hog this for 2 seconds.
Oh.
I think one thing to remember is use case isn't just the domain, it's also whether it's industry, government or research.
Absolutely.
So I used to work, I'm Vance Kelly, I work for Queensland Government. For a time I worked for the Geological Survey here. They've got an incredibly impressive core store. Not far from here, you can actually go and book a time to see it if you're a geoscientist and you're interested while you're in Brisbane. But they have this wonderful collection with internally minted PIDs, government identifiers, but unless they've been given to a researcher to take a sample from, they're almost guaranteed to not have an IGSN. They have the metadata to take one, but they usually don't have one because they've been collected by industry. And while I've got the mic, I'm just going to say, I think Rolf made a really, really important point before that probably needs to be highlighted again, is the initial reason that a sample gets taken is not the extent of its use.
Yes.
And I also am not particularly optimistic of a universal metadata standard, but I actually don't think that matters so much. You just have to understand that some domains overlap more than others. So archaeology and geology are perfect matches. They will have lots of common data. We should not expect those to have the same metadata as a battery because that's functionally based.
You took already parts of what I wanted to say. When we talk about use cases for IGSNs or for sample IDs in general, I would say the most of the use case that interests me the most would be tracing the history of the sample. So a sample might be collected somewhere, might be created in some lab, might be investigated in another lab with different methods, and might then be traveled to yet another institution. And we don't need to collect all the information gathered on that road in a single sample record, because all these, say, treatments and investigations and whatever happens to the sample creates data sets.
Exactly.
And we need to link these data sets to one single, say, picture. And for that, we need an ID to connect them. That is the most important thing.
It just, the challenge there, I think, is that that requires really everybody to use that identifier. And that has been so far, at least in the world of IGSN, and I really want to acknowledge there are other sample identifiers out there that people use. But
IGSN gains traction right now.
Right, exactly. But I think that's one of the biggest challenges still with the persistent identifiers, is that when it comes to publications of data sets, when it comes to publication of the science, there is no consistent and broadly adopted way of citing those persistent identifiers that makes actually a machine-readable process feasible to figure out that trail of history, that provenance. So that's a big, I think, effort that we also need to take on in really saying where are those identifiers in metadata. I mean, DataCite has them in as related identifiers, and there is some level, but not every repository that holds data for samples actually reports the IGSNs in the metadata of your DOI. So, there's a whole other set of activities that we need to take on in this group.
I'm pretty new to the sample world. So my name's Chantal Ridsdale. I'm with Ocean Networks Canada. I'm a librarian by trade, so the physical samples piece is pretty new to me. I was just wondering if there's any opportunity to leverage federated search things. So in the ocean space, there's the Global Ocean Observing System. And I'm not saying it's a simple fix or a simple thing, but is it something that, since it's interdisciplinary, it is important for discoverability between the disciplines to have access to be able to find these things? Would that be something worth putting effort into at a high level to see what that looks like internationally? Like, this Internet of Samples seems like a potentially great foundational opportunity that's already international traction.
I love that idea, because I think the ocean sciences or ocean data community has actually been ahead of many others, and samples have not stayed at a very high level, and the oceans are an incredibly powerful example for different types of samples: biology, geology, water, atmosphere. There's so much to do. I love that suggestion. I think that's really, really good.
I think we are a little bit moving in circles, and as I said at the beginning, what we need is to agree on a little bit of standard, and we already have ISO standard, we have IGSN. So just take all the use cases and have a look like it is done with a DCAT. Just try to consider what is wrong there, or what can I use this as a backbone of my work? For example, IGSN. I'm doing it in my material science group. Yeah, I'm reading IGSN. What is there? What I cannot use? That's the first step, and what is missing. But if I am missing something, is someone else? Does they need specifically this thing? If not, then it's a specific job for my schema, for my specific use case. But only the generic things we need. So we need to, now the first thing is to read if there is something wrong in IGSN at the very, very high level. Probably not.
Do you want to?
And I also wanted to add to Rolf, this is in industry, you have a product passport, and the sample passport can sort out your provenance and whatever is happening with you just take the model which already exists as an industry standard.
Oops. No?
Hey again, Megan Wong again. I just thought I had to do a plug for someone that's not here. I had a great demo of the CEDA metadata thingy where you can go, right, here's a minimum profile, and then you can create like a space, and then communities can just take that minimum and then just see what they need to add, what's applicable. So you can have multiple instances in this one file, just like a Google Drive. And anyway, there's just an idea.
It's
If I may, I don't know if anyone else had their hand up. Just to riff on what I said earlier, I recognize there are a lot of different identifiers already in this space, and I know that from coming from a librarian perspective, doing crosswalks between metadata standards can be really useful, especially if we do move towards a federated approach. That could help in getting to the end goal, and that could be something that we could do short term to make the long-term goal more attainable.
Just one, as an addition to, references to IGSN and what is missing and so on. Kirsten had that slide with the 3 groups of metadata that were originally envisioned for the IGSN, and it was really, some high-level administrative metadata. And then it was more of an agreement. This could be, the core for the IGSN, but ultimately, the IGSN did not have any mandatory metadata beyond what was in the administration, and it was intentionally designed that way to leave a lot of flexibility to individual groups, institutions, and so on to implement these identifiers with the information that they needed in their local applications. So, we've moved on because I think the application now has, of these identifiers, has gone beyond the initial purpose of just having a globally unique reference for every object. Jens.
Jens Klump, CSRO. I would quickly want to put the cat among the pigeons by asking a word that I haven't heard in this session yet, even though it's been all over this conference. That's AI. What could the role of AI be in solving this problem? To what degree do we need? To what degree do we need Web 2.0 semantic technologies to achieve what we want? I'm not advocating that we should abandon all of this, but maybe it's also an aspect that we could discuss. And
I think
the hand went up first, and then
certainly AI will help, but AI can help with the details. You still, for AI, or better say machine learning, you need standards. Otherwise, you will use all the power we are now producing just to find one sample record. So it is good to start somewhere, and then with the details, where consensus will be extremely difficult or doesn't make any sense anymore, this is where machine learning and AI can help.
We would have a pretty good training data set with 13 million samples.
Well, one of the challenges and a requirement of AI is that it needs access to the information. And so currently for us, we have a large number of samples. We're using IGSNs. We have our own profile of what the metadata that we supply. So we're part of the problem, not part of the solution maybe. But that information needs to be somehow accessible so that AI can consume it and make sense of it. If we didn't have some definition of what are the important pieces of information, it would all still be locked inside of our internal management systems. It wouldn't be available to AI to consume. So if nothing else, you may not have to have a standard that you follow, but you have to have an understanding and agreement of what is important to communicate so that AI can see it and then make those inferences and so forth.
But then when I think of that suggestion, it comes to basically saying you could leave a lot more freedom to the different domains, because it doesn't all need to be structured the same way, or it's a powerful argument against actually trying to build one common ring that binds them all, but rather make sure that every domain says these are the components in the information that really matter. Sorry.
The follow-on from that is, yeah, you could do that. As you say, what is accessible? The follow is, what do we want to be accessible within that? is, are you really sure you want that consumption to be occurring? Is the follow-on from that, and that is no longer a technical problem. Now we have a governance problem that we're dealing with. So, yeah, I'll put that on the table because there's a lot to unpick if we want to pick that one up.
Yeah, so I guess what Jens referred to, we were both at a session before lunch that was titled something like, will AI kill persistent identifiers? And the answer was, on one of the slides, within 10 years it will kill them. That was very optimistic, I think within like 3 or 4 years. But what does it practically mean for this community? Perhaps it would make sense to try to start refining prompts that would be trying to return similar data that a GSN search is returning and see how performance of these prompts changes with respect to straight search, and eventually that will kind of put some kind of time horizon on what we do here.
Wow.
Sorry, that's not optimistic.
Yeah, it's the question, you know, what do we need to do to bridge that time frame? How much effort do we put in now in order to let it all go?
As a quick follow-up on that, though, the question isn't whether AI can find it. It's the question of whether it can find it the second time. You know, if the result is that you don't end up in the same place, there you say that's not the solution to the problem, is it? Helps us to generate the content, but as I say, isn't the point to go back and find where the sample was and reuse it?
So Ilya and I were in the same session, and but I actually would say I'm more with Kerstin on this than with Ilya. I think there is a role for the PIDs in this that will not that quickly go away. But I think that I do agree with Kerstin's statement that less structure could mean more freedom for domain-specific applications, and these kind of technologies would allow more freedom than the Web.2 world of semantic technologies that for now, I find it a bit ironic that one of the standards is called Shackle.
Yeah, we have time for a couple of questions, maybe, or comments, and then Jens can wrap up. But I thank you all. I want to thank you all for the contributions, because I think it's been an interesting discussion and having some very positive, some more negative, some visionaries, and that's been very inspiring, I think. I just wanted, if there are no questions at the moment anymore, and I know we've lost some people, I was just curious to see, some people raising their hand and telling us if they are from other domains with respect to samples that have not been mentioned here. I mean, we've had biology, we've had earth sciences and archaeology, material sciences. Are there any, I've personally been approached also by the medical sciences for human tissue samples, where there are, yet another aspect of sensitive data and so on. So I'm just curious, is anyone here whose type of sample has not been mentioned before? Oh, cool.
A painted window on a church.
Oh, fantastic.
So in material science, we are analyzing how protective materials are being changed with the climate and with the local environment. So the sample is a painted window or a surface of a cathedral, which is treated and untreated, and there are two sensors checking how it is helping.
I asked that question because in the archaeology community of practice, we looked at that as cultural heritage. So it's a different way of looking at the same thing, and then you have...
Yeah, it is cultural heritage object, yeah.
But you can see, it's a pity that Esther Plomp cannot join us today. She's one of the co-chairs of this group, and her PhD was a very good example of this crossover between disciplines. She worked on archaeological artifacts, dogs' teeth as amulets, used by some community both as a spiritual amulet and as a currency. And so those things were now archaeological objects with the cultural dimension, with the spiritual dimension, and also with the geochemical dimension, because she used them to find out what the dogs ate.
I won't open up the type of sampling I do, because that's that 3-year conversation. But the genomic and sequencing samples, that would be so I'm primarily in the social sciences, we're crossed over into health sciences. That sort of the physical samples there and the rendering of those into sort of the data sets of use, that's a really important use case for us. And we don't want to manage the physical samples at all. They're often in biobanks and so forth. But those connections then, hence my point of where do you end up when you think about samples. We want to be able to trace the follow through, but that question of what are the original physical samples, we have to be referring to those other registries to do so. That's a really good cross-domain case that gets you the health and social sciences.
So I think looking at the time, it's time to wrap up and not stand between you and tea. And one thing that always comes to my mind when I'm in these kind of discussions is a scene from the film The Blues Brothers, where they offering to play at the music venue, and the manager of the music venue says, "Oh, that's great. We have both kinds of music, country and Western." But what I heard today was far more differentiated than country and Western, and I won't recap the presentations. I think you can download them from the site, but they gave us different insights into approaching disciplinary and multidisciplinary work around describing physical objects, and then we entered a really exciting discussion and controversial discussion about what is it that we want to achieve and how do we get there, and to what degree do we need to have a standardization of the way we describe physical objects, and where do we need to allow differentiation, what approaches exist from other communities, and also being asked to broaden our view beyond the research perspective also into the government and industry perspective, where sometimes similar needs exist and sometimes also solutions exist where we might adopt things that come from other domains and other sectors. This opens the question to what should this interest group do next? How do we connect with existing efforts? How do we connect with communities? And we can see that as a driving force in, for instance, the collections that are broadening in what they collect, what they need to deal with, and there's a need to respond to that. And yeah, there was quite a lot of things that I think, yeah, I also found quite exciting this very last discussion about what would be the role of AI. That is something we need to think about. We've also heard in other sessions at this conference how it could be used to enrich metadata that we need to fill into those catalogs, how it can bridge across catalogs without the need for building crossworks, how the structures that we create could act as guardrails against hallucinations or fact-checking the results generated from generative AI. So I think there's plenty of work that this group could do, and the suggestion of joining with the sample types interest group, I think, is also a good suggestion that would move us forward into also a more interdisciplinary direction. Did I miss anything?
I think that was an excellent summary.
Okay, then I'll give you 1 minute early start into the tea break. Thank you very much.